In this video, we're going to very quickly start by finding what the sine, the cosine and tangent of quite common angles like 45 degrees and 30 degrees and 60 degrees are, because these are used quite a lot in trigonometry. For 45 degrees, we can use SOHCAHTOA to figure out what the triangle is going to look like and what the opposite and the adjacent and the hypotenuse would be. Basically, if you have 45 degrees, it means that this angle here is going to be 45 degrees. We have an isosceles triangle. This side is going to be the same as this one. If this is 1, then this is 1. And if you try to get the sine of 45 degrees, then a sine of 45 degrees is going to be opposite, which is 1, divided by hypotenuse, root 2. So we start to build up a table of values there. So it's going to be 1 over root 2. And if you multiply top and bottom here by root 2, you end up with root 2 over 2. You'll see sine of 45 written in both these ways, 1 over root 2 and root 2 over 2. And the same thing applies to the cosine. The cosine is also going to be root 2 over 2. And if you divide the opposite divided by the adjacent, then you'll get 1 divided by 1, which should be just 1. Notice that you could also do this number here, the sine divided by the cosine, and also get 1. Now in this second example, this drawing here is supposed to be an equilateral triangle. So the three sides are all the same, which means that this angle right in here is going to be 60 degrees, which also means that up here we're going to have an angle of half of 60 degrees, which is going to be 30 degrees. And of course the angle down here is also going to be 60 degrees. Now, what we can say is we can call the length of each of the big sides there, we can call that 2. So we've got 2 there, we've got 2 there, and we've also got 2 over there. Now, if that's the case, then this angle way down here is going to be half of that. Right? So this side here is going to be half of 2, which is going to be 1. And then we can use Pythagoras to figure out the length of this side here, because we can just do 2 squared minus 1 squared and take the square root of that. You can do this in a longer way if you want to, but in any case, this side here is going to be equal to root 3. Now, once you've got that, you can then concentrate on this right-angled triangle here. Right? Ignore the rest, just this triangle here has, for 30 degrees, you can think of this as being your opposite and this as being your hypotenuse. So, for 30 degrees, we're going to have 1 over 2. For cosine of 30 degrees, the adjacent is going to be root 3 this time. So it's going to be root 3 over 2. And opposite over adjacent is going to be 1 over root 3, which we can equally well write as root 3 over 3. And in the same way, you can figure out the cosine of 60. If you think of the cosine of 60 degrees now, the cosine of 60 degrees is going to be adjacent divided by the hypotenuse. Right? So this is the adjacent to 60 degrees. And if you notice something a little bit unusual, well, a little bit unexpected, that it's going to be the same, exactly the same as sine of 30 degrees. So the cosine of 60 degrees is the same as sine of 30, and you can do the same kind of thing to get sine of 60 and the tangent of 60 degrees. Now, all these things together can help you to fill in this table here, which is the unit circle table. Now, all you really need to remember about this, well, there are many things you need to remember, but if you're trying to remember each of the points here, then you'll find that very difficult. What I would do if I were you is I'd try to remember what these points here are. Now it's fairly easy to do that. There's a special way of doing it. Notice that they're all divided by 2, divided by 2, divided by 2. It's all over 2 here. So the first thing you do if you're building up what all the points are, just put divide by 2, divide by 2, divide by 2, divide by 2, and divide by 2. And then on the top, on the numerator of all the x coordinates, it's root of 1 is 1, root of 2, root of 3. And then go in the opposite direction, root of 1, root of 2, root of 3. And that gives you these points here. This point here, remember, is going to be 1 across and 0 for y. This is 0 across and 1 up here. And then, if you want, for example, the cosine of 150 degrees, if you want the cosine of 150 degrees, what you do is you take this point here, you know that it's going to be reflected over here to make that 150. Now, all that's different about this point and this point is that the x-coordinate of this point here becomes a negative over here. So we would say the cosine of 150 degrees is negative root 3 over 2. If someone asks you what the sine of 225 degrees is, well, 225 degrees is down here. You would just have to take this point and know that you would have to reflect it over here, over to the left, and also way down here. If in effect the x-coordinate becomes negative and the y-coordinate becomes negative down here at 225 degrees. So the sine of 225 degrees is this number here, negative root 2 over 2. Now, we can do that, we can use this to help us give the answers to these types of questions here. So sine of 150, well, here's 30 degrees here. 150 degrees is somewhere over here. It's 180 minus 30. So it's going to be over here somewhere. It's going to be this point, but reflected over here. So what can you say about the y-coordinate of this point here? It's going to be exactly the same as the y-coordinate over here. So in this case here, it's going to be equal to a half. What you should do is try to imagine or try to picture where the rest of these values will be and figure out if it's cosine, it's going to be the x-coordinate. If it's sine, it's going to be the y-coordinate. Figure out what those values will be and put them in here, and then play the video and I'll show you the answers. So stop the video now and fill in B, C, D and E. Okay, so cosine of 225 degrees. 225 degrees is like 180 plus another 45. So it's somewhere down here. It's this point down here. It's like this point, but it's been pushed over here. So the cosine is going to be negative whatever this is. So we'll have negative root 2 over 2. For 330 degrees, that's like 360, but minus 30 degrees. So it's going to be somewhere over here. It's going to be this point, but kind of reflected over here. Now, what can you say about the cosine over there? The cosine is the x-coordinate. It's going to be exactly the same as this x-coordinate here. So in this example there, we're going to have root 3 over 2. For sine of 240 degrees, 240 degrees is going to be, one way of thinking about it is 180 plus another 60, so it's going to be somewhere down here. It's going to be this point kind of reflected over here, except the x and the y's are going to be negative. So the sine of 240 is the y-coordinate. It's going to be negative whatever this value here is. So we're going to have sine of 240 being equal to negative root 3 over 2. And here's a nice one. if you go round to 270 degrees, that's right here. What's the x-coordinate right there? The x-coordinate there is 0. That's all. Okay, so we can begin to answer other questions like this example here, example 2. Cosine of 490 degrees would be exactly the same as a much smaller angle. You're asked for it to be written in terms of the cosine of an acute angle. Now, an acute angle is one between 0 and 90 degrees. Now, let's just think this through. 490 degrees would be 360 plus another 130. So we'd end up somewhere over here. Right? So we'd be going around 360 plus another 130. That 130 is going to be the same as 180 minus 50. So there's a point over here which is going to have the same x-coordinate but negative compared with a value that would be over here. If you had 50 degrees over here, there would be an x-coordinate which we'd then have to make negative to get the cosine of 130 degrees. So what we're asked for here is just in terms of a cosine of an acute angle. We're not actually asked for the actual number. So 490 degrees is coterminal with 130 degrees. And we know that cosine of 130 degrees is going to be equal to negative cosine of 50. Therefore, cosine of 490 degrees is negative cosine of 50.